is 4 to the x plus 3 equals 1 over 8 to the 2x minus 2. Now the catch with this one is that if I give you two exponents and I ask you to solve algebraically, the only way that can happen is common base, because I can't convert it to a log. Okay? And I can't force you to do it algebraically if it can't make common base. It's outside the scope of your curriculum, which is number 4. That's why number 4 I asked you to solve graphically, because I actually can't make you solve it algebraically. It's illegal, not allowed. Okay? So for this one, the moment you have two bases with two exponents, you have to make common base. So 4, what could I make it be? 2 to the 2. And then I have to remember I have x plus 3 behind it. 8 I can make be 2 to the 3 is what 8 could be. But because it's 1/8, I make it be 2 to the negative 3. That's the only difference. So if it was 8, it would be 2 to the 3. But because it's 1/8, it's 2 to the negative 3. Okay? Now you can always double check yourself. You can go 1/8 into your calculator and you can go 2 to the negative 3 in your calculator and they'll match as the same decimal. So everyone try it out so that you trust me. 1 divided by 8 in your calculator. And then 2 to the power of negative 3 in your calculator. They match, right? So if I ever want to bring that number from the denominator up, I just raise it to a negative number. Okay? So, and then I have 2x minus 2. So then I distribute here, and I get 2 to the 2x plus 6 equals 2 to the negative 6x plus 6. And once I get them to be the same base, what can I do? Set the exponents equal, yeah. So we get 2x plus 6 equals negative 6x plus 6. I can add the 6x. And I get 8x plus 6 equals 6. Remember, I just pick an x and move it, right? If there's an x on both sides, you pick one and move it. You don't overthink it. And then we minus 6. So I actually get 8x equals 0. Divide by 8. And x equals 0. Now remember, we can check it with our calculator, or we could plug it back into the original by verifying. So if I want to verify, this would be my left side, this would be my right side. I would have 4 to the 0 plus 3. I just fill 0 in. I'm verifying x equals 0. And then I'd have 1/8 to the 2 times 0 minus 2. This is going to be 4 to the 3. And then this is going to be 1/8 to the negative 2. If you type this in, you get 64. If you type that in, you get 64. So they match. Right? So we know we're right. Boom. Done. Okay? That's a common base question. All right? Flip over. You're doing one on the back. So it's going to be a repeat, different numbers. Okay? Think you can try it out? Repeat, different numbers. So say I give you 9 to the x plus 1 equals 1 over 27 to the 2x minus 1. 9 to the x plus 1, and this would be a solve question still. 1 over 27 to the 2x minus 1. What base can I make them both be? 3. So try that one out. So 9 is what? 3 to the 2. And then we have x plus 1. 27 is 3 to the 3. right? 27 is 3 to the 3. But this is 1 over 27, so it's 3 to the negative 3. 2x minus 1. And we distribute through. And we get 3 to the 2x plus 2 equals 3 to the negative 6x plus 3. And then once we have the same base, we can set the exponents equal. So we get 2x plus 2 equals negative 6x plus 3. Add 6x. And I get 8x plus 2 equals 3. And then I'm going to minus 2. And I get 8x equals 1. Divide by 8. X equals 1/8. Which we're going to check with our calculator this time. Okay? So let's check with our calculator. How do we check with our calculator? We type in the original. So this is my y1. Remember, if you have the older calculators, your exponent has to go in brackets or it'll fight you every time. It won't get you the right answer, which would really stink. So everyone's trying this out. 9 to the power of x plus 1, and then 1 over 27 in brackets to the power of 2x plus 1 will be your y2. So y1, y2, typing them in. Make sure your exponent is in brackets. Whenever we do y1, y2, what are we finding? Where the two graphs do what? Intersect. So we're going to go second, trace, 5, enter, enter, enter. And what do we get? 0 decimal, pardon? 125. And then if we go 1/8 in our main screen, 1 divided by 8, we hope to goodness it's the same thing. Is it the same decimal? Yes. So if this was a multiple choice, would we actually have to solve it properly? Why won't I do the crap out of that thing if you really wanted to? Right?
Oh, I put in the wrong numbers. I added in the wrong.
All right. We're going to go back to the other side. I'm writing them down. I forgot. My brain's halted. Okay. On the other side, you have solve 2 bracket 3 to the x plus 3 equals 8. Either way, whether it's common base or not, when it's exponential, we have to move that 2. How do we move that 2? Divide it over. So we are going to get 3 to the x plus 3 equals 4. Then I ask myself, can I make a common base with 3 and 4? No. If I cannot, I must go to my formula sheet, and take off y equals a to the x, double-headed arrow, x equals log base a of y. I just take that off of it. And then I match. Now I have to decide, did I give you an exponential or did I give you the one with the word log? An exponential. How do I know that? Because it doesn't have the word log in it. Literally, that's what I do. So I have to figure out, first off, if I can figure out which one to match it to, most people can get this correct. So this is an exponential. I'm going to match it to the exponential. How do I know that? Because this one has the word log in it, and this does not have the word log in it. Do you see that? This has the word log. This does not. Do we see that? So I'm going to match the red with the red. Now, which one of those is y? 3, x plus 3 or 4? The 4, because the y is by itself. Do you see that? So this is y. This is a. This is x. So the first thing I do is match exponential with exponential. The next thing I do is write the other equation below it. Now people will skip that step, sometimes get it wrong. So I never skip it. I will write the other equation below it. So I used the red one. I'm going to write the other one below it. X equals log base A of y. Okay? And now I fill in variable for variable. X is x plus 3 equals log base A, which is 3, y, which is 4. Whatever's beside the y, I always put in brackets. Because the moment you press the log button, a bracket's going to pop open anyways. So you might as well put the brackets there. Now, if I ask you to change to exponential or to log, which I asked you to do yesterday, you would stop. If I ask you to solve, you have to get it into x equals, correct? So what's the last thing I'm going to have to do to get x by itself? Subtract 3. So I get x equals log base 3 of 4 minus 3. Now, in the new calculators, did not mean to do that. In the new calculators, I can go math, arrow up to log base, and literally type it in the way it looks. Get out of whatever I just did. Math, log base, 3, 4, and the minus 3 does not attach to it. And I get that answer. Or in the old calculators, you'd have to go log 4 divided by log 3, hit enter, and then minus 3. Same answer. It's negative 1.74. Yeah. Yeah. Everyone agrees? Or if it's a multiple choice, it could literally just be log base 3 of 4 minus 3. That could be the multiple choice answer. Not a decimal at all. Okay? All right. Flipping over. On the back side. You're trying this number 2. Solve. 3, 7, the x plus 1 equals 12. Try that one out. We're solving this one. What is our first step? What's our first step? Divide the 3 over. So when I have a number in front, this is like the initial and the final in the word problems we did, right? We're going to be practicing a bunch more. So we get 7 to the x plus 1 equals 4. Then I ask myself, can I make a common base between 7 and 4? My answer will be no. So then I have to go to my formula sheet. Y equals a to the x becomes x equals log ay. And I say, does this equation have a log in it?
How do I get the log from the old calculator?
You have to do the division thing. You can't get it. So with the x here has a log, this doesn't. So I'm not going to match it with the log one. I'm going to match it with the other one. Y is by itself and the 4 is by itself. A is the base. X plus 1 is x. And I rewrite my log formula underneath. X equals log base A of y. I get x plus 1 equals log base 7 of 4. And then what do I have to do? Subtract 1. And what do you get? Can you take it in? -2.9, we'll say. Okay, please bear with me. We're going to try this out. Y1, Y2. Type into your Y1, 7 to the x plus 1. Make sure your x plus 1 is in brackets. 7 to the x plus 1. Make sure your x plus 1 is in brackets. And in your Y2 you have 4. Second trace 5. Enter, enter, enter. Rows find the intersection of the two. And what do you get for your x? Negative 0.29. Get that? Awesome. Okay. 3. I ask you to solve log x plus 1 with a 9 beside it equals 2. Now I told you the moment that you have an x in the base of the log or an x beside the log, you have to convert to exponential every time. Every time. There's no other option. That's literally what you have to do. So if the x is in the base or the x is beside the log, you have to convert to exponential. So I have to go to my formula sheet. Y equals a to the x becomes x equals log base a of y. Which one does this one match? This one has the word log in it. So it has to match the one with the word log in it. This one matches this one. Do you see that? Log, log. If it doesn't have a log, it matches the other one. That's how you can narrow it down. Look for the word log. If it's there, it matches the log. If it's not, it matches the other one. So let's match up the letters now. 3 pieces, 1, 2, 3. 3 pieces, 1, 2, 3. So the one that's by itself is x. The base is a. One beside it is y. Now I use the log one, so I rewrite the not log one, because that's what I'm converting it to. I'm converting it to exponential. Do you see that? So now I'm going to get y, which is 9, equals x plus 1 to the 2. How do I get rid of a 2? Square root. So I'm going to get 3 equals x plus 1. I'm actually going to get plus or minus 3. I'll show you in a second. Because whenever you take the square root, you take plus or minus. We agree? And then I have to subtract my 1 over. So I'm going to get negative 1 plus or minus 3 equals x. That's actually 2 solutions. Do you see that? You're going to have 2 solutions. This is going to break into x equals negative 1 plus 3 and x equals negative 1 minus 3. So this one is x equals 2. This one is x equals negative 4. Now remember, beside a log or in a base of a log, you actually can't have a negative. So the negative 1 is going to go away. So if you didn't have it, you would have lucked out anyways. Because if I plug the negative 4 in, I'm going to get log of negative 4 plus 1. Like I can type it into my calculator. I'll try it out. I'm going to verify that one. So I'll bring it over here. So I would type it into the original. And when I go to type it into the original, it's x plus 1. So it's going to be negative 4 plus 1 down here. And then beside it is a 9. And it's going to tell me not happening. That's what it's going to tell me. So this negative 4 one is actually extraneous. What you need to know is when you plug it into here or beside here, if I get a negative in the base or a negative beside my log, it doesn't work. The number beside my, in my base has to be positive. Same with beside here. It has to be positive. And then the 2 would work. Because I would get log base 2 plus 1 plus, with a 9. So I'll show you with the 2. Let me go quick. So this one would be math log base 2 plus 1, to try the other one, and 9. And the answer to that is 2, which which is what the answer is. So it actually works. So the only answer is x equals 2. Yeah. Yeah. Number 4 just wants you to solve graphically. So what am I going to do? y1, y2. Try it out. y1, y2. That's it. So my y1 is 3 to the power of x plus 1. Make sure if you have the old calculator, it's in brackets. And then 2 to the power of 2x minus 1. And why can I only do this graphically? Because it's 2 exponents and I can't make common base. I can only ask you to do this one graphically. I can never ask you to do this one algebraically. Never, ever, ever. It's not allowed. So I type them both in, and I go second trace 5. Enter, enter, enter. And it gets me 6.2. Done. That's it. I cannot ask you to do this one algebraically. It's outside the scope of 30-2. So for number 4, your answer would be x equals 6.2. That's it. No work shown. They could ask you to explain how to do it. y1, y2. You have to go that. So they could ask how to explain it. You could go y1, y2. Yeah. All right. Flip to your notes, please. So how do I solve a log? What's the only way you can solve a log? Unless if the x is beside or the x is in the base. What's the only way you can solve a log? Convert to exponential. That's it. That's all. So what do we have to do? Write our equation out. Y equals a to the x becomes x equals log base a to y. So which one am I matching it up with? Log, because it has the word log in it. So I'm going to get a, y, x. What equation am I going to write below? Y equals a to the x. So I'm going to write x plus 3 equals 6 to the 4. What is 6 to the 4? Make sure you're following along in your notes. 1296. So I go x plus 3 equals 1296. Subtract 3. X equals 1293. Can I check it? Absolutely. I can go log base 6 of 1293 plus 3 and see if it gets me 4. Correct? Like I can type that into my calculator. So I'm going to do that. I'm going to go log 1293 plus 3 divided by log 6. And I get 4. It matches. It's the same. I know I'm right. I move on. Okay? B. What am I going to do? It is a log, and the variable's in the base. When the variable's in the base, I have to convert it to exponential. When the variable's in the base, the variable's times the log. I have to convert to exponential every single time. So this is x. It's by itself, and I'm using the log one because there's the word log in it. Beside log is a. Besides that is y. So I get y equals a to the x. And y is 144. A is b. X is 2. How do I get b by itself? Square root it. Just plus or minus. So b equals plus or minus 12. What's the catch? Yeah, your base down here can't be negative, correct? So b equals 12 is the only one that works. The next one, the b is in my base. The variable's in my base, so I have to Convert to exponential. It's not an option. So I line them up. And I get a in the base. Y is what beside. X is here. And I rewrite my equation. Y equals a to the x. Y is 123. A is b. X is 3/2. How did I get rid of a squared? I square rooted. How did I get rid of a 3/2? Technically could 3/2 root it, or I could raise it to the power of 2/3. But let's 3/2 root it for now. Sounds really stupid, but we're gonna do it anyway. So we're gonna 3/2 root it. How do I get to the 3/2? I'm just gonna rewrite this so you can actually see it. It's running into the line. That is not. That looks like it's in front. 3/2 root of 123. If you want to put anything in that index, you can go 3/2. Math number 5. You can put anything in that index you want. So in your calculator, you're going to go 3/2 on your main screen. 3/2 in brackets, so your calculator knows it's a fraction. 3/2, right? And then I want to put it in the index. So I go math number 5, because look what's here, an x. So I'm just putting it in for the x. Now mine actually wrote as an index. Yours might just put it in front. Still putting it in for the index. It's the same thing, okay? And then we put in 1, 2, 3. 24.7. D has done the worst out of all of them. You want to know why? You guys convert it. Where is the y? By itself. This is the only time you don't convert it. You just type it in your calculator. So it's done the worst, people will convert and then they get the y stuck in a spot they can't get it out. If your y is by itself, you literally just type this into your calculator. Type it in. Log base 36 of 6. Or if you have the old calculators, you're going to do log 6 divided by log 36. So if you have the old calculators, you're going to go log 6 divided by log 36, which is 0.5. Or you can use, if you have the newer calculators, this button, and it'd be log 36 with a 6 beside it. Either way, it's 0.5. There's the your turns, E, F, G. Why is it not moving? Did it freeze? Oh, goodness. So, I'm going to pick a few. I want to pick one, this one over here. So, I would have to line my logs up, so I would get, I'm scared to even change this, I don't know. I would have y equals a to the x. X equals log base a of y. So I would have x, a, y, and so then I have y equals a to the x. So I would have y, which is 24, equals b to the 5/2. And how do I get rid of 5/2? 5/2 root it. That doesn't sound stupid at all. Did anyone get the answer to this? B equals what?
3.62.
I can't hear you.
3.62.
3.62. Did everyone else get that? Yeah. We have some agreements.
Oh.
Okay. What's the problem with H? Yeah, 1, 2, 3, 4 options. I can only have 3. So I need to get rid of this 2. How do I get rid of it? Divide it. So I get log base 6 of x plus 1 equals 2. And this is x, this is a, this is y. Y equals a to the x. X plus 1 equals 6 to the 2. x plus 1 equals 36. Subtract 1, x equals 35. Then we're going to flip over to the next side, which is going to make us solve exponentials that we can't make common base. So, can I make 4 and 7 a common base? No. So if I can't make them a common base and I have one exponent, I must convert it to a log. Y equals a to the x is the exponential one. So this is my y, this is my a, this is my x. And it's going to be x equals log base a of y. So now I'm going to get x equals log base 4 of 7. I type that in. X equals 1.4. It's the nearest 10th. What's my problem with B? That plus 4, right? How do I move it? Minus 4. So I get 8 to the x equals 36. Can I make 8 and 36 be the same base? 8 and 36 be the same base? No, I can't make them be the same base. There's one variable, exponent, so I can convert it to a log. So I'm going to line it up. Y is the one that's by itself. A is this one. X is x. Then I write my log equation. X equals log base a of y. So I'm going to get x equals log base 8 of 36. And I get 1.7. What's wrong with D? Too many terms. 1, 2, 3, 4 terms. I can only have 3. So what do I have to do first? Divide by 2. It's a lot like the question we did before. 3 to the x plus 3 equals 4. Can I make 3 and 4 be the same base? No, so I have to convert it to a log. Y is the one by itself. A. X. So x equals log base a of y. So x plus 3 equals log base 3 of 4. And then I have to subtract my 3, which we did this one. Log 4 divided by log 3 minus 3. Negative 1.7. You guys are doing E, F, and G, and we're going to go through them at the beginning of class tomorrow. E, F, and G. Now you should be able to walk away from doing them knowing if you're right or wrong, because what could we do? Y1, Y2, and check. Could we not? Every single time to solve? Y1, Y2, Y1, Y2. So we should be able to come tomorrow knowing you're good or you're not. Okay? So E, F, and G.